So today we are going to cover limits. We are going to cover the chapter for limits. So before in high school, you were used to do f prime of x is equals to limit when h approaches 0 of f of x plus h minus f of x divided by h. So this one was a first principle. We call it the first principle. So when we call it the first principle, you can maybe get an equation. For example, maybe if you have y, which is equals to x squared, then we can find f prime of x of this x squared. Then when we find f prime of x of this x squared is going to be equals to limit when h approaches 0 of f of x, when the f of x is this one here. So our f of x is x squared. So which means we're going to say brackets, where there is x, we're going to put x plus h squared minus x squared over h. So expanding this, it will give us a limit when h approaches 0 of x squared plus 2xh plus h squared minus x squared over h. So this one will cancel with this one. Then you're gonna be remain with you'll remain with a limit. Let's say limit when h approaches 0 of 2x, whereby you have h and h here. We can just write 2x plus h in brackets. We write h, we factorize over h. Then this h will cancel with this one. Then we'll be left with limit when h approaches 0 for 2x plus h. So now, because this h is approaching 0, normally many students, when they take it, they say it's like you are going to substitute 0 there. H equals to 0. H is not really 0. So h is just approaching. So we just ignore this h, and then the answer now, it becomes 2x. So now this answer, we got it by first principles. First principle. So in this module, this one was a high school standard. So now when we deal with when we are dealing with a limit, so we are going to be guided by some few rules. So we're gonna have limit. We're going to have a limit. We're gonna have a limit. Let's say, for example, when n approaches, it can be infinity, maybe f of x, which the results, it can give us L. And we can also have limit when n maybe approaches. You can also use maybe x. It can be x approaches infinity, positive infinity. Let me just write positive here. Positive infinity. Okay. Maybe let's say positive infinity when f of x approaches x, which is equals to L. So this implies this, what I've written here, if I'm only using only this one. So this implies that as n approaches positive infinity, then f of x approaches what? Approaches L. So even the same one applies. It applies that if L approaches infinity, then f of x approaches L. So you can be given a function. So a function, you can be given a function like the way we did it when y equals to 2x. But now here, let's say we also have the left, let me say left, before I do an example, the left limit and a right limit. Left limit and a right limit. So the left limit is if I have my limit, when let's say n, it can be, I'm gonna give with a countable example. Let's say it's 2 to the power negative f of x. Then this is equals to f of 2 to the power negative, 2 to the power negative. So this negative on top here, it indicates that this limit is a left-handed, left side limit. And the right side limit, if we are using also the countable, is going to be limit when n approaches, let's say 2 positive, f of x, then our answer is going to be f of 2 positive. So what is the meaning of these 2 positive and negative? So when we are dealing with limit, we have something called absolute. We have absolute value. When we talk about the absolute value of, if I is a function, let's say a function of f of x, whereby equals to absolute value of x. So this absolute value of x, it implies that is x if f(x) is greater than 0, and is negative x if x is less than 0. So here is going to be greater than or equals to 0. And this absolute value of x, when we say is x equals to 0, it means that if you have to draw the absolute f of x in a Cartesian plane of x and y, then in the Cartesian plane, the graph, it goes like this way. It's a straight graph, just that my writing here is not showing straight. So in this one here, this is the graph of absolute value of x. So when it's a graph of absolute value of x here in the origin, so if here is 1 and this side is 1, negative 1, then if the point here, they go exactly the same, like that. So this is an absolute value. So it have a side of negative 1, and it also have a side of positive 1. So the point here, when we say it have a side of negative 1, then which means we can find the limit for this side. We can also find the limit for another side, the right-hand side. So now this drive us that, it's gonna drive us that if now, if we have a limit, when n, if it's approaching 2 to the power negative 1 of f of x, and this limit is equals to limit when n approaches 2 to the power positive. So if these two limit from the right-hand side, left-hand side equals the right-hand side, then this implies that the limit when n approaches 2 of f of x, here I should have written f of x. The limit when n approaches 2 of f of x exists. It exists. So this is just a formula. This is just a theorem. So in this theorem here, it was invented by a squeezy. It's called a squeezy. Sandwich squeezy. Yeah, sandwich squeezy, something like that. So now if we have this here, let me just erase here. So now we might be given a countable. We're going to start with a question. We might be told that a limit when n approaches, let's say 2, whereby for f of x, then, and we are given f of x, let's say f of x equals to x squared plus 2. So we have to find the limit when x, not n, here I'm gonna change to x, when x approaches 2. So in order for me to find the limit when x approaches 2, then I'm gonna write it as, like, I will say limit when x approaches 2 of my f of x is x squared plus 2. So which means it's going to be x squared plus 2. So x squared plus 2, then in this one, it's not the same as the first principle. Here now, when you want to get the limit, you can just substitute to the equation 2x there. You can say it's 2x squared plus 2, then which is going to give us 4 plus 2, which is equals to 6. So this implies that as x approaches 2, then f of x approaches 6. So sometimes you can be given an example. Let's do another example. You can be given f of x, which is equals to, let's say, x squared plus 3 over x plus 1. Then you're asked to find a limit when x approaches, let's say, 1 of f of x. So to answer this question, then our answer is going to be limit when x approaches 1 of x squared plus 3 over x plus 1. So according to the law of limit, if you have a limit, for example, these are just a law before we continue to that question. If you have a limit of x approaches, let's say it's a is just any number of f of x, and also let's say f of x, and then yeah, okay, limit when f of x. So let's say if our f of x, it's in the form of, let's say, x squared plus x plus 1, then you can be able to say is limit when x approaches a of x squared plus x plus 1. Then you can write it as limit when x approaches a of x squared plus, also you can say limit when x approaches a of x plus again limit when x approaches a of 1. So this is, you can also use that method. And then this, even for subtraction, even for addition, we have f of x, which is equals to g of x over h of x. And we are finding the limit when x approaches a of f of x. So this is the same as you can write as limit when x approaches a of g of x over a limit when x approaches a of h of x, and the results can also be g of a over h of a. So this is another rules. So if you have also a limit, let's say your f of x equals to g of x plus h of x. So to find the limit of this can be limit when x approaches a of g of x and plus limit when x approaches a of h of x. So which we can write it as equals to g of a plus h of a. So now when we solve this limit here, the one we have been doing, then we can write this as a limit when x approaches 1 of x squared plus 3 over, we can put brackets there, over limit when x approaches 1 of x plus 1. So after that, the answer, it can be limit of this when x approaches 1 is going to give us 1 plus 3 over 1 plus 1, which is equals to 4 over 2, and which is equals to 2. So if we do the examples, there is a study guide here. If you check the example in the study guide, so unit 1 point in introduction to, and then okay, then we're just gonna go straight to the question introduction. If you have time, you can read that. I think it's just a welcoming message. So if you check here in your study guide, they will start by showing you limit like f of x. If like this one is just a matter of showing you what happens. This one is the left-hand side, the one I was showing you. This is just a graph of the function that they are doing. So if you find a limit, they are showing you that if limit of f of x when it equals to 4 for this function here, when it is positive, we are still gonna do that. So this one, they are just trying to show you what happens. So if L equals to that and equals to the limit, this one I already show you, whereby if the left and right limit they are equal, then it means that limit of f of x exists. The way I've written it there. So if we go to questions, yeah, these are the things that I wanted. So they said determine the following limit. So if you check here, we have limit when x approaches -1. So normally when you write it, you will have to just follow the steps the way I was doing it. When I say limit, then you substitute 1 is gonna be 1 plus 1 cubic is 1, is gonna be 2 over negative is gonna be 0 over, if you put -1 here, gonna be -1 plus this one plus 1, then the answer is gonna be 0. The answer already is 0 for this one, but we can compute it. So if you check, so let me just write it down. So it says limit when x approaches -1, x cubic plus 1 over -x squared plus x plus 2.
Yeah,
okay. So in this one here, if we substitute, let's say we put -1 cubic plus 1 over this big plus 1 over negative, in bracket -1 squared plus -1 plus 2. So the answer here you're gonna find that is -1 plus 1 over -1 minus 1 plus 2. So the answer becomes 0 over 0. So the limit of 0 over 0, remember, anything divided by 0 is undefined. So this limit here, it becomes wrong. The answer, we cannot say equals to 0. Cannot be equals to 0. So there is something that we call it hospitality. Hospitality. I think I'm writing the right spelling. Hospitality. So the hospitality, it says we must differentiate everything which is there. So the way I've taught you yesterday how to differentiate this. So when we write it, we're gonna say limit when x approaches -1. So if I have to differentiate this, I will say d over dx. But normally, if you are writing, you don't really have to write d over dx. I'm just writing it because I'm showing you how it's supposed to be done. So d over dx and d over dx of -x squared plus x plus 2. So this implies that this is going to be equals to limit when x approaches -1, then the d over dx of this is going to be 2. So it's going to be 3, the way we did x squared. So when it's 3x squared, the 1, because it's constant, is going to be 0 over, then d over dx of this, we're going to be -2x, going to be -2x plus 1. So now when we're left with this, we can check something. What will happen you check the denominator. What will happen in the denominator if you put -1? So now if we put -1 in this equation, is going to be positive. It's going to be positive 2. positive 2 plus 1 is going to be 3. And what will happen if we put negative 1 squared here is going to be 1 times 3 is going to be 3. So now it won't give us, in the denominator, it won't be giving us a 0. So now we can say this is equals to 3 in brackets negative 1 squared divide by negative 2 negative 1 plus 1, which is going to give us 3 over 3, because this one is 2 plus 1, then the answer is going to be 1. So this is how we get the limit. So if you go to your study guide, it's 1 point, we're dealing with number 1, and taking note that here it was negative 1, not the one for left, it will be indicated on top. It will show that it's negative 1 on top or positive 1 on top of the number. So if we go to how they also answered it, you will see that here when they answered it here in your question, they used a limit when x approaches, they factorized. When they factorized everything there, they go but they still get the same answer that we get. But we used what? We used the method of differentiating. So I will tell you that it's better when you are working with this kind of limit, you use the method of what? Differentiating. You're still going to get the same answer. And this one helps you that if sometimes when you are factorizing, maybe cubes, it gets more complicated because sometimes we'll have to use long divisions. So which can consume a lot of time. Any question?
No, so far you're right.
Right, okay. So
Yeah.
if we check also, there's, let's say maybe we want to do question number 2. Question number 2, it states that question number 2, I will do this one. It says limit when x approaches negative 3 of x plus 3 over x squared plus 4x plus 3. So if I want to find this limit here, if I substitute 3 here, what will happen? Will I get 0? That's the first thing that I'm going to check. If I say 3 squared is going to be, 3 squared is going to be negative 3 squared is going to be 9. And then 12, 4 times negative 3 is going to be negative 12. But positive 9 plus minus 3 is going to be minus 3. I mean, positive 9 minus 3, 12 is going to be minus 3 plus 3 is going to be 0. So when it's going to be 0, this means that this equation, it won't be worked. We need to differentiate. So when you do it, you just write your limit. When x approaches negative 3, then you differentiate. When you differentiate, you don't really show the way I was showing d over dx. You can just write differentiate here. You know that if you differentiate x is going to be 1, and then the 3 is going to be constant. You leave it as it is. Then when you differentiate this one, the denominator is going to be 2x plus 4. So now we check what will happen if we substitute negative 3. If we substitute negative 3, it's going to be 2 times negative 3. 2 times negative 3 is going to be negative 6 plus 4 is going to be negative 2, which is not equals to 0. Then we can say this is equals to 1 over 2 in brackets negative 3 plus what? Plus 4, which is equals to 1 over negative 2. So the answer is negative 1 over 2. So this is how you do it. If you check there your memo, then in your memo, maybe they might have written it, but you can see that here they are factorizing. If you also love this method of factorize, you can try to factorize, but I think I will say dwell in that method because you're still going to do it, apply it in many questions. So this is how we get
So-
negative.
So every time Rico factorizer, also the Rico differentiator, x is an exponent, it becomes 1. It
If you are
becomes 0.
differentiating,
Sorry. X is an exponent, like just a plain x.
yes, it becomes 1. But it's not necessary that it becomes 1, because of if you have 2x and you are differentiating 2x, the answer is going to be 2. Because the recent part on top here, that is 1.
1.
It's going to say 2 times 1, x 2 times 1 into x 1 minus 1. Then the answer is going to be 2 to the power x to the power 0. And anything to the power 0 is what? Is 1.
It's 1.
Then
Okay.
the answer becomes 2.
Okay, thank you.
All right. So here you can try also to, in this exercise that I was showing you, you can try to pick any question. You use the same method, then you will see that you're going to get exactly the same answer that we have been doing. Anything, they can look complicated, but it's still the same process that I was using. So you just check what will happen. For example, if we are working with this one, what will happen if I put 2 negative 2 here? You can see that if you put negative 2, it's going to be 4. If you put negative 2 here, it's going to be plus 4. Then which means this equation is going to be, this equation is going to be a, this equation is going to be a what? Undefined.
Yeah,
So now
undefined.
in mathematics, I can use other method. You see, here I can, like in mathematics, we can check something that is similar to something. If you check this equation up here, is x squared minus 2x is the same as this one on top here. So we can also say we can let our u equals to what? We can let our u equals to x squared plus x squared minus 2x. When you let your u equals x squared minus 2x, then you substitute u inside this equation. When we write limit when x approaches negative 2, this is another method that I'm just using. It's going to be u over 1 over 3 minus 2 over u minus 8. So now, because here my x approaches what? My x is approaching negative 2. So I can instead of u, I can say u equals to, I put negative 2 here on top. It's going to give me 8, is it? 2. Negative 2 squared is going to be 4 minus 4 plus what? Plus, it's going to be 4 plus 4. It's going to give us 8. So instead of using x equals to 2, because here my function is in terms of what u, I will use u here. Then I'm going to use 8 here. Positive 8. Let me just erase properly. Yeah, let me erase. Okay. So I'm going to use u when approaches what? Approaches 8. When I use u approaches 8. Then even still, if I put u equals to what? 8 here. If I put 8 here, you can see that it's going to give us 0. So now I can differentiate. It's more easier for me to differentiate. When I differentiate this, I will say my limit when u approaches what? Approaches 8 is going to be equals to 1 over 3 u in brackets 1 over 3 minus 1. If I say 1 over 3, I subtract by 1. This is going to give us 1 minus 3 is going to be minus 2 over 3. Yeah, going to be minus 2 over 3 over what? If I differentiate this one, I'm going to get 1. Then now I can just put my 1 over 3. Where there is u, I'm going to substitute with what? With 8 to the power negative 2 over 3. So 8 to the power negative 2 over 3. Remember, 8, it can be written as 2 to the power 3. It's 1 over 3. You can write it as 2 to the power 3 in brackets negative 2 over 3. So this 3 is going to cancel with this 1. Then we're going to be left with 1 over 3 in brackets 2 to the power negative
-2.
Then the answer is going to be 1 over 3 dot 1 over 4. Because 2 to the power negative 4, 2 to the power negative 2, you can write it as 1 over 2 to the power 2, which then 2 to the power of 2 is 4. Then I will say this is just a dot. Then the final answer can be 1 times 1 is 1. 2, 3 times 4 is 12. Ne? So our answer now, we got 12. So when we get 12, this is indicating that our limit when u approaches 8 of what? Of that, I will just say f of u equals to what? 1 over 12. So if we check this answer here, you'll find that the answer that I worked it with a different method. Ne? I was trying to simplify my life so that I don't go through a lot of steps whereby I will have to be differentiating in different ways. Then, if we go to check here in our answer, we would do number what? Number 11.
Number 11.
If you go to number 11, you will see, do you see that your answer is 12?
Yes.
But I worked it in different method, in a simplified. So in mathematics, we can work in different ways, but we get to the right answers. So I was just showing you that. So why am I showing you that is that when I'm teaching you, I'm gonna teach you things that are going to be more easier for you to understand. But it does not necessarily mean that someone can use this method. It does not necessarily mean that that person is going to be wrong. So in mathematics, the answer, they can be the same, but the steps, how we solve the problem might be different. So, which means if when lectures they are marking, when the tutors, normally people who mark, they are tutors like us for your assignments and maybe your like your assignments and like exam. So when they are marking, they check the steps. They don't check which step is like, which kind of step did you use? We check the steps, and we also check, it depends on the question can be stated that use only this method. If the question says use only that method, that's when you only apply the method that they want. But if they don't specify, then you can also use another ways to get to the answer. So in this one here, in question number 11, the one I just give it to you, if you check here, you can still differentiate using what? You can still use the same, the method that I was using before. Let me erase first. Okay, it's fine. Yeah, okay, it's fine. I'm gonna erase. I will come back to that question. So we can still use a method. Yesterday, I think I gave you 2 methods of differentiating. So I'm not sure if you managed to understand them. The method that I gave yesterday, I gave you how to differentiate using the product rule and the quotient rule. Did you understand how to do that?
Yes.
So now I'm going to introduce you on another method called a chain rule. We call it a chain rule. So chain rule, it states that if you have a function which is f of x, and in this function f of x, you can have x plus h, maybe to the power a. Then when we find f prime dy over dx, which is still the same as equals to f prime of x, and this is still the same as equals to y prime, then we take this a down here, then you say brackets x plus h to the power a, you subtract by 1. This 1a I'm using, it can be any number. Then you differentiate what is inside here. Then I will just use as d over dx, d over dx of x squared x plus h. So in a countable example, if I have a function which is f of x equals to, in brackets, x squared plus 2 to the power 3. So if I have to find my dy over dx, so my dy over dx is going to be equals to 3 is going to go down, in brackets, x squared plus 2 to the power 3 minus 1 d over dx of x squared plus 2. Then this is going to be equals to 3 in brackets x squared plus 2 to the power 2. When we differentiate this one, the answer is going to be 2x. It's 2x because this 2 is going to go down and 2 is a constant. We just ignore it. Then maybe you can simplify it if you want to simplify it. When you simplify it, remember this is going to be 6. 2 times 3 is going to be 6x in brackets x squared plus 2 squared. Then you can just say this is 6, sorry, 6, not 8, 6x. Then this is going to be x to the power 4 plus 4x squared. X to the power 4 plus 4x squared plus 4. Then you can multiply by 8x. This is going to be 8x to the power 5 plus 32x to the power 3 plus 32x. But normally when we are working with calculus, this one, you can also end here in this step here. This is 2, yeah. You can end there, it's not a problem. But if you want to simplify further, you can also simplify until this stage. So this is how we work with a chain rule. So this is the method we use with the chain rule. So let's go back to that equation. In this equation here, so in this equation, we can write, we can say, okay, we can differentiate what is inside there. It can still be a limit when x approaches -2. So when you differentiate this one, you know that is going to be 1 over 3 in brackets x squared minus 2x. And then 1 over 3 is going to give us -2 over 3. Divide by, you would differentiate what is the denominator, going to be 2x minus 2. So now if we put -2 here, you can see that it's going to be negative, it won't be equals to 0. Then now, remember, we just differentiate this, but I'm not yet done with differentiating this because I still have to differentiate what is inside there. I have to differentiate what is 2x minus 2, and 2x minus 2 is going to give me 2x squared minus 2x, going to give me minus 2x minus 2. So this is the complete differentiation using a chain rule. So now, after doing that, then I can substitute back. I can substitute my -2 to this equation. If I substitute -2, it's going to be 1 over 3 in brackets. -2 is going to be negative what? -2 squared is going to be 4. Minus is going to be plus 4 again to the power -2 over 3. Then I substitute -2, there is going to be -4 minus 2, which is -6 over, if I substitute -2, it's going to be also -6 because it's going to be -4 minus 4 minus 2 is going to be -6. Then this one, it can cancel with this one. Then you're gonna be left with 1 over 3 in brackets what 8 to the power -2 over 3. Then this will give us the answer of 1 over 3. Now you know that 2 to the 8 is 2 to the power 3. Then it will give us 2 to the power -2. As the 3 will cancel with the 3 there. Then we're gonna be left with 2 to the power -2. And 2 to the power -2, we know that is going to be 1 over 4. Then we're gonna be 1 over 4. And your answer is going to be 1 over 12. So now I just use the other method whereby I was differentiating, the one I'm teaching you using to differentiate first. Then we're gonna get 12 over 4. But let's try to see how these guys here who wrote this memo, how is he doing it? So you can see that the first thing here, they completed, they used, I think, okay, I think the method they are using is completing by square, but I'm gonna check that now. They wrote this one here, multiply by x squared minus 2x to the power 2 over 3 minus. So if you check, do you see this method is confusing? Because you don't even know where this come from. It's not getting clear. They divided by this one, where the way they divided here. This thing divided by this one, we all know that equals to 1, né? Which is still the same as equals to this. But where exactly did they get this? So if we check here, where exactly they get this, you might find that it shows that they are completing by the square, whereby they first use this method here for 8. They completed 8, x squared minus 2x minus 8. Then they get that this is going to be x squared plus what? Plus 4 minus 8. Then they substitute. So that method is very complicated. It's something that I cannot even, I cannot waste my time trying to understand what this person did there.
Okay.
So, yeah. So then some other method, they are more of complicated, because this person, he was using his own reasoning capacity. So the method that I'm showing you now is very simpler compared to stressing, as you can stress a lot trying to find out how did this person do it. So now, using the method that I'm giving it to you, just pick any questions here, try to do them. Any questions, practicing, and then check in your study guide if you are getting the same answer. I have proven a point with many questions here that I'm getting the same answer. I didn't do this question yesterday. I'm starting to do these things with you today. I don't study anymore. I just wake up and open and check what we're gonna teach. So I'm gonna proceed again. I want to see what is going, okay. This one we already talked about, okay. This one we haven't talked about. So if you have a limit, when your x is approaching plus or minus, if you have 1 over x, let's say your x is approaching plus or minus infinity, the answer is always 0. So this is just a note that you must remember. So now when you have limit when x approaches infinity, so what we do, now they are teaching you that method. Okay, they are trying to come to that method that I was teaching you. But here, if you check, they divided by x, né? They divided by x, but we can also try to check, okay, what can you do if we can differentiate first. Let's differentiate and see what will happen. We can be 12x over 4x plus 7. So now with this one here, when we do this one, you can, because of this limit is infinity. So every time when limit is infinity, you must take the one with a higher order of degree, degree. So when you take with one with higher order degree, the objective is to that we must have 1 over x, because we know that if it's 1 over x, the limit when x approaches infinity of 1 over x equals to 0. So every time when you work with these ones, check the one with, like, for example, in this one here, we have x squared. So the x squared there is the one with a higher order degree. You divide everything with it.
Mm.
When you divide everything with it, then you're going to have limit when x approaches infinity of, let's say we are dividing this, is going to give us 6 minus 1 over x squared, ne? Divide by 2 minus 7 is going to be plus 7 dot 1, 7 over, this one is going to cancel with x squared. There is going to be what? X7 over x. Ne? So 7 over x, when we write it, this is still the same as limit when x approaches infinity. So 1 over x squared is still the same as equals to 1 over x, ne? To the power squared. So this is still the same as if we are finding the limit of this. If you have a limit of x approaches infinity of, let's say, 1 over x squared. This is the same as equals to limit when x approaches infinity of what? You can write 1 over x squared, because squared like this is still the same as this one, if you can agree with me. Because 1 squared is 1 and x squared is going to be x squared. So when you have this, you're allowed to say this is the same as limit when x approaches infinity of 1 over x in brackets squared. Ne? And this limit here inside is going to be 0 squared, which is equals to 0. So now, if we have this, now you can agree with me, this answer is going to be 6 plus what is 0, because limit when 6 is going to give us 6. Limit when this one is going to be give us 0 over 2 plus what? Plus 0. Because 7 over x is the same as 7.1 over x. Ne? And 7.1 over x is the same limit when 1 over x equals to 0. 7 times 0 is 1, is 0. So the other thing that I can maybe teach you now is that if you have a limit when x, let's say, approaches, even if not only infinite, it can even be 2, ne? Let's say it's 4, it's just a constant like this. This is the same as, you can write this as 4 limit when x approaches 2. Then if there is nothing, it's just a constant, the answer becomes 4. Do you get it?
Yeah, and which is it?
Okay, if a limit when x approaches, let's say, 5 of 7 over x. Let's use infinity for now. Ne?
Okay.
Yeah. Then this is the same as limit when x approaches infinity. This 7, we can take it out here. Then we're going to be left with 1 over x. And we know that limit when x approaches infinity of 1 over x is 0. Then this is going to be 7 multiplied by what? Multiplied by 0, which the answer is going to be 0. So the moment when you understand this, some of the things when you are writing, you're gonna minimize. You don't have to really show. You can just write something like this and write the answer. So the point is to understand exactly what is happening. So here the answer is going to be 6 over 2, which is going to be 3. And it's exactly the same method. So if we can proceed here, you will find that you have this kind of equation. Maybe you can pick one, we do any number.
Can we do the one with the square root?
This
Number
one,
17
okay.
and number 19.
19, okay, 19. So if we are going to deal with number 19, let me just erase. I will try to write here in this board, then I'm gonna erase again. So number 19, it says limit when x approaches negative infinity of square root of x squared plus x plus 2x plus x, and this x is outside of the square root. So when we write this one here, this is the same as you take inside, I'm just gonna say equals to, then you're gonna write a square root inside. This is going to be same as limit when x approaches infinity of x squared plus 2x plus again limit when x approaches infinity is negative infinity. Yeah, 19 is negative in infinity of x. So now what happens? So now when you check this, when we check it, what happens when x is approaching infinity? When the number is keeping going to the negative side. If we draw a graph of x, for example, we're drawing a graph of x. A graph of x is the graph of like this way. So you can see that the more this thing is approaching infinity, is going, it keeps approaching what? Also negative what? In the side of y, negative infinity. And now we can also check this one here for this one inside here for x squared plus 2x. So when we check this one is also the same as limit. We can rewrite it as equals to limit when x approaches infinity, negative infinity of x squared here is going to be x in brackets x plus 2. X in brackets x plus 2. So now when it's x in brackets x plus 2, we can see that here, the way it is happening, we can differentiate. We can use that method of differentiating. So when we use that method of differentiating, let me just write this one in the board so that I can write properly in this body. Is square root of x squared plus 2x plus, okay. So now with this one here, remember this one is going to be equals to, we must first solve this answer here. We must first solve this one. This is going to be equals to, we are going to divide it by the highest degree, the highest is gonna be x squared. So you're going to say limit.
So we
when
don't start by
x,
solving the bracket or anything.
hello?
We don't start by solving the bracket or anything, removing the square root and everything. We just solve it as it is.
You mean like solving?
Like it in a square root for. Aritomingo remove a square root solve raro.
Like why solve your
Okay.
Yes. But that limit were infinity. Then for this square root here, we are going to say square root of, but it means a square root. Okay, sorry, I'm making mistake. Apparently, let me just erase it. Then we're gonna use this method. It's not really complicated, but we're going to put inside square root. We're gonna say this is a square root of what? X squared plus 2x. Then is plus again limit when x approaches infinity of x. Okay? Then this is going to be equals to limit when x approaches negative infinity. This is negative infinity. I'm just forgetting to write negative infinity there. Then we are going to divide by x squared there. Inside here is the square root. You're going to divide by x squared. When we divide by x squared, we're going to get 1 plus what? We can put brackets inside. 1 plus 2 over x, ne? Plus this one here for limit when x approaches negative infinity. We can divide it by x. When we divide it by x, we're going to get 1. Then this is equals to square root again, limit when x approaches negative infinity of 1 plus 2 in brackets limit when x approaches negative infinity of what? 1 over x. I'm using the standard rules. Plus limit when this one, if it's 1, is we're just gonna write 1. Then after that, this one here, limit when x in the side the square root here is going to be 1 plus limit when this is going to be 2 times, we know that 1 over x is 0. Then it's going to be 2. Ne? 2 times 0 is 0 plus 1. Ne? Then we're gonna be left with square root of 1 plus 1, which is 1 plus 1, which is the answer is 2. So if we go to the memo, it's number 19. Eh?
Yeah.
The answer, okay. Let me see how we got okay, plus 1. Let me check properly. Oh, yeah, okay. I'm not sure if I'm the one who copied it wrong. Number 19 is negative infinity. Everything is positive here. Okay, let me check how this person did it. And number 19, negative 1, okay. So the square root, okay, is fine. Negative infinity x squared plus, okay, it's fine. It's fine, it's fine. It's okay. Then limit one, this one, multiplication, this one. X squared plus 2x plus minus x squared, that is 2x. Square root of this. A positive 1.
Hi, John. No.
No, probable. If you check this one here, this question here, somewhere some wrong, this person did some mistake here, because it's using the same method that I'm using. Because if you check here, he divided by x squared. Ne? When he divided by x squared, he got 1 plus 2 over x. And then after that minus x, this one is fine. But he introduced this absolute value here, this absolute value. And this absolute value that he introduced, I'm teaching. So this absolute value that he introduced here is there is no cancellation of it. Just came minus plus. So it somehow he did a mistake. Somewhere, somehow, there was a mistake that he did, because probably we cannot just introduce something and without the cancellation, because this cancel this one, you're gonna remain with 2x over this one. When you divide here, where did he get this absolute value? So there is a problem that he made. Maybe they wanted to introduce something there. So this question is not really clear.
Okay.
Because even if it's introducing this absolute, since absolute value, we all know that absolute value can be cos negative x since x is less than. But the problem part here, this negative x is multiplying it, and it's supposed to be negative x, and also here there must also be negative x, so that it can cancel, because everything must go back to normal. So somewhere there is a mistake here. Okay, so I'm gonna also verify it, but there is a mistake. Probably there is a very huge mistake there. Because even if when you get the limit, when it's like this way, if we substitute inside, according to the rules of the limits, 1 plus 2 over x, you can use inside the square root there, like to get the limit when x approaches negative infinity. Like this one is going to be 1, this one is going to be 0. So it's going to be negative. The answer is going to be negative what? Negative 1 minus 1, which is going to be minus 2, which is fine. It's going to give him 2 over minus 2 is going to be minus 1. This one is right. Is the matter the step here, introducing the absolute value. That's when something is wrong. Going wrong. So I'm gonna verify it, Mara. His answer, I don't believe it, because the way I'm also doing this step here, normal in the simple terms, is showing that exactly the way the steps that I'm doing, they are not really they are not having a problem. Because if you have limit, if we are using the rules of a limit, this is a separate functions and this is another functions. So according to the limit laws of the rules of a limit, if you have f of x, which is equals to h of x plus g of x, then when we find the limit of x approaches maybe a, this can be of f of x. This can be equals to limit when x approaches what? A of h of x plus limit when x approaches a of g of x. So these steps that I applied is the step that I applied here. So I'm gonna verify that one so that I can be sure that maybe am I the one who made a mistake, but I don't think so. So maybe Bangaba, you can be also doing others, like maybe you can try the other ones.
Okay.
Because here the only rule that they want you to know is that when you have 1 over x equals to 0. So you can try to apply the other ones. So limit involving absolute values, okay. So the first thing that this one, I think I already mentioned it the first time we're doing in our lesson. So when we say absolute value of x, let's say if we are saying equals to 0, this means like it's the same as x equals to 0 or negative x equals to 0. So normally when we have a question, like maybe we have this one here. I'm not sure if I'm gonna be confusing you, or if we should first maybe focus on the ones that we have been doing. I mean, maybe these ones here.
Let's focus on what we've been doing or on this one.
Yes, because this one for absolute value, I'm going to be speaking something very different from, something very different from what we have been doing. So I think maybe you can just pick up few of the exercises here. Then you try to do them, and then you check if you are getting the right answer based on the method that I have been teaching you. Okay. Then maybe we're gonna continue later. I'm not sure what time you're gonna be available again.
What time?